Hey everyone, I know this video is long overdue. A lot of you see the power of effect, but have been asking what it looks like in a day-to-day project. So I thought we could build an app together from scratch, see how everything ties together, and that's precisely what we're going to do. So what are we actually building? We're going to create an AI-powered writing assistant. So the core idea is to build an app where you can define your own reusable transformation styles. So these are custom instructions or personas for the AI. So for example, you could create a style that make that tone more casual or rewrite these to be more idiomatic. But obviously it's all up to the user, so you can get much more specific and nuanced and whatnot. So maybe translate this technical jargon into a simple explanation for a beginner. So once you have defined these styles, you can feed the app any piece of text. So you maybe click a button and it will generate several new versions for you based on that style. So for example, it could be 4 generations. So this would be concurrent by default, but this is configurable for the user, maybe at a maximum. And the cool part about this is we're going to stream in everything directly to the client in real time. So you will see all of the different versions appearing on your screen at once as the LLM generates them. So you know we need to manage concurrency, we need to add telemetry to see how long those operations take, and also we need interruption. What if the user closes the browser? Well, we need to interrupt the generations. So what about the tech stack? Well, everything's going to be in effect. So what does that mean? That means that we're going to be using add-effect RPC. So this will let us define our procedures, like creating a new style or generating the text transformations. Then for the real-time streaming, we're going to use the add-effect platform package, which comes with the HTTP API module. Then to persist the user-defined styles, we're going to be using add-effect SQL. So we're not going to use a heavy ORM. We'll be writing a plain runtime safe SQL just to show you how powerful, elegant, and simple this module is actually. And finally, for the front end, we're going to use add-effect Rex, and that's to manage our state and react to the data streams from the backend. Now, a quick note on this, I won't be doing a super deep dive into our Rex in this video, as I'm already working on a separate crash course for it. So we'll just cover the essentials we need to get our app fully working. And I almost forgot about one module, and that is add-effect AI. So as the name suggests, we can generate stuff with LLMs. And with this, we can have better retries, better provider fallbacks. What if Anthropic is down? How do we fall back to another provider, etc. Now, a quick and important disclaimer. A lot of these effect packages are still pre-1.0, so they are not officially stable. However, and this is a big however, there's a very good reason we're using them. The truth is there's nothing else in the TypeScript world that comes close. The ability to build such reliable code is a huge advantage. That's the trade-off for being on the forefront of this. I use this full stack in production, and the reason is simple. It lets me build better apps faster. My users get a more solid product, and that's a benefit that for me far outweighs the risk of a few breaking changes in the future. So enough talking, let's start. So for this, I have scaffolded a project, setting up all of the dependencies and also the PNPM workspace Monorepo. So you can find the repository in the description if you want to go along. Now, the reason why I decided to scaffold everything beforehand is because this takes time, and configuring things is always the most boring part. We want to sit and write code, and that's exactly what we're going to do. So for this, I have a README where I go over the whole installation, the prerequisites, etc. But in short, we have 4 packages. We have the client package, which is just a single page application with Vite in React. We have the database package. So here we define the migrations, we define the actual database client, etc. Now the reason this is its own package is mostly for future proofing. Maybe you're going for a microservice architecture or whatever, then you can just use the same database client for all of them with the same configuration. Though this is up to you. We then have the domain package, and here is where we're going to share the contract between the client and the server so that the server knows what to serve and where to serve it. So for example, the endpoints, the RPC procedures, and well, the client will consume that to, same thing, know where to hit the backend. Now I also have some files here. I believe we're only going to be using my extension of the effect logger, which we're going to see what it actually does in a moment. But these are files that I almost always bring with me. These are extensions, if you will. So they might be worthwhile to look into, see how each one works, and see if you can borrow something. And finally, we have the server, which, well, it's just going to spin up everything and set up the endpoints and the like. And that's pretty much it. So let's get started. So for this, I'm going to run the client. Let's make sure that this actually works. So I'm going to say pnpm and install. Once we have that, we can say pnpm filter client dev. And okay, it is running fine. And we get the hello world here. And what about the server? Well, for that, I actually set this up with Dino, but we're not going to be using Dino. So we're going to change this to just use Node. I believe we can say tsx watch and then point it to the root file. And if I say filter server dev, it works. We get the log, this log right here. Now, aside from that, we need our database service and the telemetry because we're going to set everything up with OTel. So for this, we have this Docker Compose. So make sure to have this running. So for this, I'm using orbstack. And if I say Docker Compose up and then -d for detached mode, we should get RPC tutorial with Jaeger, which is the all-in-one OTel processor. So we can view the traces there and it's going to collect them as well. And we have our Postgres instance running. So we're going to be using PostgreSQL for the database. Great. So now that we have this, where should we start? Well, the most logical part or place would be in the server. We need to actually set up a server where we can listen to health check requests. So for this, we're going to say HTTP live, and this is going to be a generator. Now, I just noticed we do not have the language service extension from effect. So let's see where that should be defined. So here we have the plugin, but we're not getting any completion here. Maybe it's the TypeScript version. Yeah, so we're using the VS Code version, so make sure to use the workspace version. And that way, if we do this and restart the service, when you type gen, notice how we get this nice autocomplete. And this works for a lot of different modules, which we're going to be seeing throughout this video. So actually, before we do this, I think I should explain how to do it the high-level way, as in the declarative way of setting up your HTTP live implementation. So for that, you would first create the API. So you can say API is equal to HTTP API.make, and then you can provide an identifier. So this is basically a namespace, or, well, as the JS docs state, a collection of endpoints. So you can use HTTP API to represent a portion of your domain. So here what you can say is API as your global identifier, and then you can say .add. And notice how you can add HTTP APIs. So you can create a top-level namespace, and within that top-level namespace, you can have two sub-namespaces. For example, a private versus public API, which we're going to do in a moment. But for now, for simplicity's sake, we can say just .add, and here you can pass in, or you must pass in, a group, an HTTP API group. And this is your way of bundling different endpoints within one namespace. So here you can say class and then health group extends and then HTTP API group .make, and then you pass in an identifier, which in our case can simply be health. Now, why an identifier? Well, that's because an HTTP API will allow you to create a client of it, pretty much like a TRPC client, where you can say API dot and then the namespace and then dot and the endpoint. So in our case, we would get API dot health, since we know health is the group. Now with this, we can add endpoints. So we can say add and then HTTP API endpoint, and then we can say get, post, put, whatever. So here we can say get, and then we pass in the path, so what it will actually be for the REST API. And then we can add success and then schema.void. So it is not going to succeed with anything, or well, we can say schema.string. And again, what is this name here? Well, this is the identifier, but for the endpoint. So it is going to construct it like API.health and then .get. And once you have this, we can then add this group, because here when you say add, it is expecting you to pass in an HTTP API group. So you can say health group. So with this, we now need the live implementation for this API. So notice how we have HTTP live. Well, in effect, for every interface that you're going to have, you'll most likely have the live implementation. So what you're actually going to use when your application is running in production. So in this case, we can say const API live and then HTTP API builder, and then we pass in the API. And what are we going to get back? We're going to get back a layer that is going to succeed with HTTP API.API. It is not going to fail with anything, but it is going to require the health group. So notice how everything is kept at a type level. So you know that if you want to run this API live implementation, you likewise need to provide the live implementation for the health group. So how can we do that? Well, this is a layer. So we can compose it and we can say layer.provide and then health group live. And as for health group live, well, we can say HTTP API builder .group. We pass in the API. So for which API? Well, for this one right here. Then what's the group? So this one right here, same identifier. This is important, obviously. If you just do heal, then you're going to get a type error. Health is the only one available. And then you provide the actual builder or the constructor itself for the handlers. So this right here can be an effect. You can say handlers, and this returns an effect.gen, and then you can say yield effect.log debug, and then you can say health group live, and then you can return the handlers, and then you can say handle, and then what endpoint? Well, you get type safety here, so get, and then you can succeed with an OK. And that's it. Once you have this, notice how this is a layer that is going to succeed with API group or health. It is not going to fail with anything, and it is likewise not going to require anything. And so once we provide the layer, you'll notice that it is going to exclude from the final layer whatever it is that you're providing here. So this right here. So as you can see, if I hover over API live, it is not going to require anything. Great. So what else do we need? Well, we need the HTTP live. So notice that this is just the live implementation for the API, but who is actually responsible for setting the middleware, the error handling, the loggers, the actual setup of the server and the listeners? Well, that's where HTTP API builder.serve comes into play. So as we can see, build an HTTP app from an HTTP API instance, which is our live instance, and serve it using an HTTP server. So by doing this, it is now going to require an HTTP server, so it knows how to actually run the server, set it up. It is going to require some default services, which are irrelevant for us. At least this is all abstracted for us. And well, it is going to require the actual API, which again, this will be satisfied by this API live. So if we pipe this through, say layer.provide and then API live, as we can see, the HTTP API.API requirement just went away. So now we're left with default services for the HTTP router and then the HTTP server. So for that, we can provide another layer where we say node HTTP server and then layer, and this one will succeed with those. So as we can see, it is going to succeed with HTTP platform, generator, and I believe node context, which are all of the dependencies under default services. And then as for the HTTP server, it is likewise going to succeed with that. So with this, we have basically satisfied all of the requirements and we get a layer that doesn't require anything. So great, but what do we need to pass in here? Well, we need to pass in what we're actually going to create the server with, as we can see evaluate. So we need to say create server, and this comes from node HTTP, and then we can pass in some optional options such as port. So we can say 3000 and that's it. We can then come here and run this. But how do we run this? This is a layer, a constructor. Well, we need to convert this into an effect because we know we can say effect.runPromise, runsync, etc. But we cannot do layer.runPromise, for example. That wouldn't make sense. So here we can say layer.launch and then HTTP live. And this is going to do exactly that. It is going to take the layer and it is going to translate that into an effect, passing in the same error channel. So the effect can fail with the same errors that the layer can fail with, and it is also going to require the same requirements of that layer. In our case, it is not going to require anything, so we're good on that. And then we need to run this. So we can say node runtime.run main, and this is going to, as the JS docs state, provide built-in error handling, logging, and signal management. So for teardown, if you stop the server, it is going to do it gracefully, basically. And that's it. Now, what I like to do is still log any errors that do occur when constructing everything, so we at least know what went wrong if something went wrong. So here we can say effect.tap error cause and then just an effect.log error, which I believe run main doesn't do by default. So if I come here to make run main, we can see that it is going to run the fiber, but we can pass in this disable error reporting, which by default is not true. So it is going to execute this branch right here, which is going to run for this tap error cause. So all errors, whether that's an expected or unexpected error, and then it is going to log the error. So in fact, what we're doing is superfluous. Now coming back to the server, we can now get rid of this. This is no longer necessary. However, I would like to have a log that says like we're running the server, or at least the port. So at first you might think of tapping this and then saying log info and then server started at port 3000, for example. This is not going to work. Why? Because this is a never-ending fiber. It is only going to be terminated if there's like a defect at the construction time. So in that case, what we can actually do is remove this pipe, and we can come here and then say HTTP server and then with log address, and this is a layer. So as we can see here, takes in the layer and it is going to do an effect.log saying listening on and then the port, or not the port, but the address. So they use layer.effect discard, which is a way for you to run an effect, but since this is not going to succeed with any service and implementation, you just want it to log, then you can just discard it. As we can see here, constructs a layer from the specified effect, discarding its output. And that's it. So with this, if I save this, we should be good to go, except for the health group. We need to prefix this. So notice how we have identifier health. So this is for us to be able to do api.health.get and also for the implementation. But when we hit this, if we do /health and then a get request to the root, that's not going to work. So this will actually be registered at the top level. So we need to prefix this whole group by saying /health. And as we can see, add a prefix to all endpoints in an HTTP API group. Note that this will only add the prefix to the endpoints before this API is called. That means that everything that comes before this will have the prefix. But if you define another HTTP API endpoint, then this will be registered at the root. So the prefix will not apply. So great. Now that we have this, if I come here to the terminal and then come here to the server process, as we can see, we get listening on and then port 3000. So if we do a curl request, as we can see, we get back okay, and well, everything works as intended. Awesome. And there we have it. Our server is officially up and running with a live health check. So we have laid the essential groundwork for our application. Sure, we still need to wire up the endpoint that will handle our RPC logic, but we're already starting to see how the pieces connect. I know layers can be one of the trickiest parts of Effect, so it was great to see how they compose together to launch our server. So in the next video, we're going to establish our first real-time connection to the client. We'll set up a streaming endpoint using server sent events and get it hooked up on the front end with Effect.rx. So if you want to follow along with the series, make sure to subscribe. Thanks for watching, and I'll see you in the next one.